Hello there, welcome to today's chemistry video. In this video, we'll be doing the Cambridge IGCSE Chemistry Specimen paper for examinations in 2020. This is the second part of paper 4, the theory paper. Question 6. Soluble salts can be made using a base and an acid. Part A. Complete this method of preparing dry crystals of the soluble salt cobalt 2 chloride 6 water from the insoluble base cobalt 2 carbonate. I know the names of these compounds make it confusing, but first focus on what we have to make. We have to make dry crystals of soluble salt. Now the question said that soluble salts can be made using a base and an acid. We're given with a base here, so we need to add an acid in order to make the soluble salt. That's why it's given here. Step 1. Add an excess of cobalt 2 carbonate to hot dilute hydrochloric acid, so the soluble salt will be made. For the next step, we need to filter this mixture to obtain just the salt. Step 2. Filter the mixture. We have the salt, but it is not in the form of dry crystals, so we need to heat it and allow it to crystallize. Step 3. Heat the residue and allow to crystallize. Once it has crystallized, make sure it's dry. Step 4. Dry the crystals. This type of questions can be solved easily as long as you know all the experimental techniques and when you should use each of them. This question asks to find dry crystals, so we have used crystallization here. Part B. 5.95 grams of cobalt 2 carbonate were added to 40 cm cube of hydrochloric acid, concentration 2.0 mol per dm cube. Calculate the maximum yield of cobalt 2 chloride 6 water and show that the cobalt 2 carbonate was in excess. We have the chemical equations and a list of equations that need to be answered here. It looks quite complicated, but if we do these questions one by one, step by step, they're all doable, so don't worry. So the first question is asking us to find the number of moles of HCl used. From the question, what information did they give us about HCl? They have given us its volume, 40 cm cube, and its concentration, which is 2.0 mol per dm cube. Well, what is the formula of finding mole using concentration of a substance? It's concentration multiplied by volume of the liquid. Mind you, the question has stated that it's 40 cm cube, not dm cube, so we need to change it to dm cube, which gives us 0.04 dm cube as its volume. So the answer is 0.04 times 2.0 equals to 0.08. Next, number of moles of COCl2 formed. From this equation given, there are 2 moles of HCl and 1 mole of COCl2, telling us that the ratio of HCl to COCl2 is 2:1. Therefore, since we found out that there are 0.08 moles of HCl, there will be 0.04 moles of COCl2 after dividing it by 2. Number of moles of COCl2 6H2O formed. So this compound appears in the second equation given here. We have just found out the number of moles of COCl2, so we can make use of that. The ratio of COCl2 to COCl2 6H2O is 1:1, so the number of moles of COCl2 6H2O will be 0.04 as well. Then they have given the mass of 1 mole of COCl2 6H2O. It's 238 grams. This is the relative molecular mass of the compound. And they have asked us to find the maximum yield of COCl2 6H2O. Maximum yield here means the maximum amount of mass that can be produced. So we need to use the formula number of moles equals to mass divided by the relative molecular mass. Since we are finding the mass, we can rewrite the equation as mass equals to number of moles times the relative molecular mass, and that will be 0.04 times 238, giving 9.52 as the final answer. The first part is just asking us to find the number of moles of HCl used, so we can write 0.08, the exact number from the above question. Then the mass of 1 mole of COCO3 is given as 119 grams, which is the relative molecular mass. Now we need to find the number of moles of COCO3 in 5.95 grams of cobalt-2 carbonate. They have given us the relative molecular mass and its mass as well, so we just need to do our calculations. Number of moles equals to mass divided by relative molecular mass. So 5.95 divided by 119, and that will be 0.05. Part 2 is asking us to explain how these calculations show that cobalt-2 carbonate is in excess. When we want to find out if a substance is in excess, we need to compare the number of moles. We have just calculated that 0.05 moles of COCO3 were used in the beginning because the question said 5.95 grams of it were added. But in the end, from our previous calculations, we can see that only 0.04 moles of COCO2 was formed. And even though the ratio of COCO3 to COCO2 is 1:1, therefore we can say that COCO3 was in excess because it produced 0.05 moles, but only 0.04 moles of COCO2 were formed. Question 7. Iodine reacts with chlorine to form dark brown iodine monochloride. The chemical equation representing this is given here. This reacts with more chlorine to give yellow iodine trichloride. An equilibrium forms between these iodine chlorides. Part A. What do you understand by the term equilibrium? This is a definition that you must remember. It's when the rates of forward and backward reactions are equal and the concentrations do not change. Part B. When the equilibrium mixture is heated, it becomes a darker brown color. Suggest if the reverse reaction is endothermic or exothermic. Give a reason for your choice. If it has turned to dark brown after heating, it means that the equilibrium has shifted to the left-hand side because here on the left-hand side, ICl is dark brown in color. And the thing about equilibrium is that they will act in an opposite way to what's happening. So in this case, when the temperature was increased, it has done something to decrease the temperature back. Therefore, we can say that the equilibrium shifting to the left is decreasing the temperature, meaning they are endothermic. The question asked about the reverse reaction, which is the same thing as the equilibrium shifting to the left. So you can put your answer as the reverse reaction is endothermic because this direction is favored by high temperatures. The phrase favored by high temperatures is used to stand for an explanation that whenever the temperature is increased, this direction will occur most of the time to decrease the temperature back. Part C. The pressure on the equilibrium mixture is decreased. How would this affect the position of equilibrium? Give a reason for your choice. The pressure depends on the number of moles on each side of the given equilibrium. On the left-hand side, there is 1 mole of ICl and 1 mole of Cl2, so in total, 2 moles. On the right-hand side, there is only 1 mole of ICl3. So when there is higher number of moles on one side of the equilibrium, we say that the pressure is higher because the more number of moles, the higher rate of successful collisions. Therefore, when the pressure is decreased, as the question said, the equilibrium will shift to the left-hand side in order to increase it back. The answer? It will move to the left-hand side. Reason because there are more moles on the left-hand side. Part 2. Describe what you would observe. Since the equilibrium has moved to the left-hand side, there will be a change in its color. The color will turn to darker brown because ICL is dark brown in color. Part D. Calculate the overall energy change for the reaction between iodine and chlorine using the bond energy values shown. Show your working. Overall energy change is calculated from the energy used in bond breaking and bond making. So first, we need to identify the bonds present in this equation. I2 has one II bond, Cl2 has one Cl-Cl bond, ICl has two ICl bonds because it has two moles. The substances on the left-hand side are the reactants, and being reactants, their bonds will break. And bond breaking requires gaining energy, so you will give a positive number. So it will be 151 plus 242 equals to 393. Then for the product side, it is bond making, meaning they will release heat and it will give a negative number. The calculation goes in this way. Negative 208 times 2. Because there are 2 moles equals to negative 416. The overall energy change will be the sum of bond breaking and bond making. 393 minus 416. The answer is negative 23. Part E. Draw a labeled energy level diagram for the reaction between iodine and chlorine using the information in Part D. Since the overall energy change was a negative number, it means that it releases heat and is an exothermic reaction. In the graph to be drawn, the overall energy level will be decreasing as a result. So let's draw it. First, draw the axis. X-axis needs to be labeled as reaction and y-axis as energy. Then draw a horizontal line to indicate the energy level of reactants in the beginning. Label it. And another horizontal line to indicate the energy level of products at the end of the reaction. Lastly, connect these two horizontal lines with an upward curve. This part should be labeled as the activation energy. And we're done. Question 8. The alcohols form an homologous series. Part A. Give 3 characteristics of an homologous series. Examples of homologous series are alkanes, alkenes, and alcohols. What identifies them as homologous series? Well, you need to memorize these characteristics. I'll just list it down here so you can see what those are. They have same general formula. Their consecutive members differ by CH2. They have similar chemical properties because they are in the same functional group. Their physical properties vary in a predictable way, meaning the physical properties may not be the same but still in a certain trend. You can write any 3 of this because it is a 3-mark question. Part B. The following 2 alcohols are members of an homologous series and they're isomers. Explain why they're isomers. Alright, so they have OH at the end, so they are alcohols. Both of them have a total of 4 carbons. The right one has carbon in a bracket, but if you just count the numbers, it's the same thing. So we say that they have the same molecular formula but different structure formulae. Part 2. Deduce the structure formula of another alcohol which is also an isomer of these alcohols. First of all, it needs to have an OH somewhere, and 4 carbon atoms are needed but presented in a different way from the previous question. Well, one method of doing this is by changing the position of OH. It does not need to be at the end. Another method of doing this is by compiling all the carbon atoms in the bracket. They all still have the same molecular formula. Part C. Copper 2 oxide can oxidize butanol from liquid X, whose pH is 4, so it's acidic. We have a graph here, the left test tube showing butanol being oxidized by copper 2 oxide, and the right test tube is where liquid X is formed as a result of the oxidation. The first question says, give the name of another reagent which can oxidize butanol. You can name any oxidizing agent, so I'll write potassium manganate 7, the most common one. It's good to memorize at least one of these agents. Next, which homologous series does liquid X belong to? Liquid X is the result of oxidation of alcohol, and what do we get if we oxidize alcohol? We get carboxylic acid. State the formula of liquid X. The formula of butanol is this. After being oxidized, it will become a carboxylic acid, so we need to add oxygen and it will become like this. CH3, CH2, CH2, COOH. Part 2. The alcohol ethanol can be made by fermentation. Yeast is added to aqueous glucose. This is glucose. This is the ethanol made from glucose, and carbon dioxide is produced as well. Carbon dioxide is given off, and the mixture becomes warm as the reaction is exothermic. The graph shows how the rate of reaction varies over several days. Here, the graph is increasing at first, reaches its highest point, then is decreasing in the curve. Suggest a method of measuring the rate of this reaction. They're asking us to measure how fast this reaction is occurring, and obviously, we'll need to measure something that can be measured. In chemical reactions like this, we tend to measure the volume of the gas produced because CO2 is the only gas present, and it is easy to measure it being formed from the aqueous substances. So the answer is measure volume of the gas and also measure the time because we want to know how much gas is produced over a certain period of time. Another tip, if the questions mention the word rate, most of the time they're related to the time. Part 2. Why does the rate initially increase? This question is related to the process of fermentation. Why does the rate suddenly increase? Well, that is because this reaction is exothermic. It's given in this question. And when the temperature of a substance is increased, the rate increases. It's simple. Part 3. Suggest 2 reasons why the rate eventually decreases. Now, we need to remember that we're using yeast, and yeast is a highly sensitive substance. Since ethanol is produced, after some time, the concentration of ethanol will increase until it will kill yeast. Another reason is because we don't have an infinite supply of glucose. We have a fixed amount of glucose, and that will be used up one day. So it's kind of a common sense question. The concentration of ethanol is high enough to kill yeast, and because glucose is used up. Question 9. There are 2 types of polymerization, addition and condensation. Explain the difference between these 2 types of polymerization. This question is a very common question that appears in organic chemistry section of paper 4, so make sure you know the answer to this. For addition polymerization, there is only one product. That is its characteristic. Then for condensation polymerization, a polymer and water will be formed. Part B. Some plastics formed by polymerization are non-biodegradable. Describe 2 pollution problems that are caused by non-biodegradable plastics. Okay, another question asking facts. So non-biodegradable products will first of all release toxins when burned, so they cannot be burned and will take up space. Also, animals may mistaken it as food and consume it, but since it is not digestible, this can be fatal to animals. Lastly, animals can be caught in plastics and suffocate, which is also fatal. Part C. The polymer known as PVA is used in paints and adhesives. Its structure formula is shown below. Deduce the structure formula of its monomer. Alright, find the pattern in this structure. We see that there are two of this compound. So there you go, you can simply write, and you're done. Part D. A condensation polymer can be made from the following monomers. Draw the structure formula of this polymer. This time, they gave you monomers and you need to draw the polymer. We can see that there are COOH bonds at each side of the left monomer and NH2 bonds at each side of the right monomer. As a result, amide linkage, CONH, will be formed in between. So if you draw it, it will look like this. Amide linkage in the middle and the rest of the elements in its same position. Also, these lines at the end, the continuation bonds should be drawn to show that more polymerization can occur. So that is all for this paper. Thank you for watching. I hope this video was helpful. If it was, please subscribe and like my channel. Also, comment down below if you have any doubts. Stay safe and God bless you guys. Bye.